For anyone who watches my regular videos, I do quite a lot of video game hacking, and there's quite a lot of boilerplate on the software engineering side that goes into that. I'd like to build a toolkit which kind of abstracts away a lot of that. It's going to be quite low level C++ and start off on Windows, but we'll see where we go. I've laid out the code kind of how I like to do a lot of these kind of projects, in that there's a library and an executable. The reason being that basically all the logic is going to live in the library, and the executable, like the command line tool, is just going to drive that library. The reason being is that if this is eventually of use to anyone, then they can either take the command line tool and use that, or they can take the library and directly embed that into their own program, their own project. So I think we need a function which gets PIDs. I think that seems a reasonably sensible place to start. So what we're going to be using is a Windows function called enum processes. So this retrieves the process This retrieves the process identifier for each process object in the system. So this is the official Windows way of getting a list of all the PIDs. We're going to be reading quite a lot of Windows documentation for this. It's more interesting than it sounds, or at least to me, because there's a lot of oddities and curios in how Windows software has evolved over time, and we're going to kind of do our best to fully embrace and conform to the restrictions and curios that Windows had provided us. So the function takes 3 arguments. The first one is a pointer to an array that retrieves the list of process identifiers. So this is an array of D words which is going to receive all of the PIDs. The second argument is the size of that array, but it's in bytes, which is kind of a bit strange. So it's not the number of elements in the array. You have to make sure that you multiply that by the size of D word. Otherwise it will be wrong. And then it will out variable, it will return you the number of bytes that it's put into that array. Again, not the number of elements, it's the number of bytes. If the function succeeds, the value is non-zero. If the function fails, the return value is 0. It says bool, but then it talks about numbers. Sure, that's fine, we can work with that. And then I love the remark section in all the Win32 APIs, because there's always a few hidden gems in there. It is a good idea to use a large array because it is hard to predict how many processes there will be at the time you call enum processes. Fair enough. To determine how many processes were enumerated, divide the LPCB needed value by the size of D word. There is no indication given when the buffer is too small to store all processes identifiers. For if LPCB needed equals CB, consider retrying the call with a larger array. So the official way that Windows provides you to get all the PIDs on your system will not tell you how many PIDs there are. It will just keep filling up your array, and if it fills it fully up, then good luck, because Windows just suggests you call that function again with a bigger array. So we're gonna try and handle all of this in code, because I think it's important to try and get these things right. Another point is that starting from Windows 7, the PS API, which is where this function lives, changed, and so it's now actually called K32 enum processes. So the docs say this process, this function, which is actually not called this function, takes an array, but you also have to think in bytes, and will not actually tell you how much data it returns. You kind of have to figure that out for yourself as you go along. D-word PIDs. So we need to effectively want to call if K32 enum processes, and then we can give it the PIDs.data, so that's the array, and then PIDs.size, that's the number of elements, don't forget to times by the size of D-word. I guess we could use decal type to pull out the type from PIDs, but I think it's easy just to type D-word. And then, we need to somewhere for it to store the number of bytes that it returned. Bytes returned, and then if that equals 0, then everything has gone wrong, and we will throw. So I think something to note, to draw attention to here, is that for me personally, I think it's important to communicate your public API in terms of like fundamental and vocabulary types. So, the fixed width integers, optionals, variants, those kind of things. Because this means that, because we could return a vector of D words, and that's absolutely fine because that's what the API says it's going to give us. But when we come to port this to Linux in the future, that won't work because dword is a Microsoft construct. It doesn't exist. And having ported a large Windows code base to Linux before in the past, I can tell you that if all your APIs are just talk in terms of types that are just available in C++, it makes your life a lot easier. Having said that, I do think it's important to communicate with the Windows API in terms of the types that it is expecting. We should speak its language and then convert those to whatever language we want to speak outside, which is basically the point of abstraction, right? Let's handle the case where we actually need to call this multiple times, because again, Windows won't tell us how many PIDs there are. We kind of have to guess. So while let's see, bytes returned equals PIDs.size over size of dword. So I'm going to have to give this an initial amount as well. So let's pick a nice round number, 1024. So this will basically format. So this will try and collect 1024 PIDs, and then every time it fills that array up, it will try again, which means we need to, on each iteration, PIDs.resize PIDs.size times 2. So it'll exponentially grow this buffer, which is a pretty standard strategy for these kind of things. So we're going to keep doubling that buffer and try and fill it until we don't fill it completely. And at that point, we know, well, we're reasonably sure there are no more PIDs because Windows has told us that. So now we need to take this vector of dwords and convert that into a vector of uint32t's, which you can't just return one vector as another and have it convert. We could loop through and copy them across, but I think instead we will use some modern C++ and try it with ranges. So let's try return PIDs, pipe that to std views transform, and then this is going to take one of our PIDs and we can return by this code at the moment doesn't actually do any transformation, it just takes the value and return it. So we could static cast this to a uint32t, but if we just we say this lambda's return type is uint32t, then the compiler will just sort out the rest for it, and it will allow the implicit cast, which will then kind of make this work. And then the final thing is to take this range and actually reify it back into a vector. So we can use 2 and then vector and then so. Okay, let's run that. And I get a whole bunch of PIDs and quite a lot of zeros. I've seen the issue. We keep looping until our array is not fully filled, which means we basically filled up some subset of this array, but we're still returning the whole array. We need to restrict this down to just the ones that we know we returned. I hope that makes sense. I think now we want to start building out a bit of an abstraction. We want to be able to take that PID, put it in a class, and then through adding methods to that class, we can start to interact with that process. uint32t PID, and then private, that will std uint32t, that will store the PID, and then we can have a getter, so std uint32t PID const, and then I think as well we will have a string name. So I think this is kind of what we should be aiming for to start with. So the name will be the name of the process that was launched, so probably something like Firefox XE or something like that. Back to the docs, this enum process page actually has a link to enumerating all processes. So this, Windows kind of gives you the code that you need to, the runes that you need to in order to get this. I think there's quite a few ways of getting the name of the PID, but let's just go with this because this is what we've got. So the first thing we need to do is open the process. This gives you a handle to it, and the handle is actually the way that you interact with processes within the Win32 API. So I'll open the process. We will then, and I'll go through like enum process modules and get a module base name in a second. And then at the end of it, we'll need to close the handle. So the thing here is that, in my mind, whenever we have like a yin and a yang, like a do and an undo, that should be encapsulated into an RAI class. So RAI, resource acquisition is initialization, is a C++ idiom for automatically handling like lifetimes of objects and making sure they get correctly cleaned up. So basically what I want is to be able to supply some sort of invalid value that is kind of part of the type. So if you think, if anyone's done any Unix socket programming before, when you create a socket, you'll get back a file descriptor, which is an integer, and that is -1 if it's invalid. So I'd quite like to be able to sort of say something like auto release int -1, and that way when I assign a socket and put it inside this container class, it already knows what the invalid value is, so it will make sure it won't call the deleter function if it's invalid. So that's kind of my thought process. Obj, and then I'm not that fussed about performance at the moment, so let's use a std function which takes will return nothing, take a t, and that will be the we'll call that the deleter, we'll make that null pointer. So we're going to want to store some data, so we're going to want a t obj, and then we're going to want a std function void. I suppose I could alias that, but what are you going to do? So the crux of this now is that when we have the destructor, we can basically say if does not equal invalid and we were supplied deleter, then deleter obj. This won't work. This is the start of the bare minimum. Let's add a few more methods before we get on to the interesting part of this class, which is how you handle transferring of resources. So const, let's actually be able to get the object out, and then I'm gonna add a cast operator which also returns the object, and this will be important later because by adding this you can then use this class in places where that type is expected. So it means we can pass this class, which is wrapping something, straight into a Win32 function, and then the compiler will just make sure that the internal value it's storing is the one that gets passed. Let's just quickly add some equality operators. So const auto release const equals default. Let's get the compiler to generate that for us. And then void swap. So we will need swap in a second, so let's create that. So I'm going to include ranges now, which might seem like a strange thing to include, but it will all hopefully make sense in a minute. Some of the historic complexities of C++, there's this thing called argument dependent lookup. So if you wanted to swap member variables and the compiler couldn't immediately see where a swap implementation for that was, it was allowed to reach out into the surrounding namespaces. But to enable that and to make sure it still found the standard ones, you had to do some like boilerplate stuff. But that has all gone away with ranges, so I can just do std ranges swap obj other dot obj deleter and then deleter. So this will just create a swap method for that. And then I guess to be fully complete, we should create a freeform function as well so that other swap methods can find us. Auto release t invalid r2, and then we should be able to just do r1 dot swap r2. Okay. So back to the last sort of salient points of this class before we actually get back onto doing some actual coding. We want to disable copying, both types, because we will this class is effectively going to be the owner of this object. It should be the single owner, very much like a unique pointer. So if you can copy it around, then when your copies go out of scope, they will try and delete the object, which isn't ideal because then you'll end up with the equivalent of a dangling reference. So by disabling copying, it means that this, when we instantiate this auto release with an object, this will be the sole owner of it. However, we still might need to transfer what's called transfer ownership of that. We still might need to be able to like hand that over to someone else when we no longer need it. So we do that with the move constructor and the move assignment operator. So auto release. So this will be called when someone is constructing us with an R-value reference, and not going to go fully into all the value categories now, but this is basically an object from which we can steal the resources for because it's no longer needed afterwards. So that's either the return value of a function, a PR value, or the result of std move, an X value, like an expiring value. So we want to basically default construct ourselves first, and then we should be able to just swap with other. So at this point here, once we've called this, we are in like an invalid state, which is why we have this. And then we basically steal the resources from the one that's been passed into us, because we know semantically that if someone's called this, then whatever they're passing to us is no longer needed. And this will take our invalid values, stick it in other, and take others' values, and stick it in ours. When you do this kind of thing, I believe the standard uses the phrase left in a valid but unknown state. So you can destruct it and probably assign something new to it, but kind of all bets are off of what state it's left in after that. So then we have one more to do, which is the assignment operator, the move assignment operator. So I'm missing an equal sign. This has one more level of complexity to it than this, because this will be called on an object that has already been instantiated. So I was going to say AR equals ... AR, as in auto release, I can't bother to type it out, equals ... And then later on we do B equals like std move A. So this says I want to transfer ownership of this object into this one, but this one already could potentially be managing an object, so we need to make sure we delete and clean up anything we currently manage before we take ownership of the new one. That's kind of the only gotcha in this. So if we create a new auto release object and std move the other into it, and then so this will effectively hollow out. This will call this, which we just discussed, and we'll basically transfer this into it. So this after this line, other is hollowed out. It's left in a valid but unknown state, and we now have ownership of this. And then if we swap ourselves with new object and then return this. So this is the key part here. By swapping ourselves with this one, after this line, we now own other because it's gone into this object and then gone to ours, but crucially anything we did own is now in new object, and when it reaches the end of the scope, it will, because of RAII, it will automatically clean itself up. So at the end of this function, we will have taken control of other, we would have freed up anything we did already own, and other will be left in a valid but unknown state. So that's kind of like an easy-ish way to implement this. Windows.h. So I know, like I just know that we were going to want to have a handle to this process. But again, by just storing a handle here, I have to remember to close it when I no longer need it, and I have to handle copying it and ownership. So instead, we can just wrap this in an auto release handle, and believe, because the defaulted template, that will work with the invalid handle, because an invalid handle is null. yeah, so now this class automatically gets that functionality. So when this class goes out of scope, it will call the destructor on all of its members, which will call the destructor on auto release, which will cause that to go away. And this will also effectively make this process non-copyable. So call open process, and we need to give it some permissions. So the permissions are an ordered set list from the access rights. So there's a whole bunch here. I'm not going to go through them all. I'm just going to pick the two that I know I need, but you could kind of read through all these if you're curious to know what you want. This basically just says what permissions this handle has on the process that it's opening. So I want process query information, so this will allow you to query the process, and I also want process VM read, so this will allow you to read memory from the process, and this will be needed to get the, if I remember correctly, this will be needed to get the name of the process because it's effectively reading memory from that process. Okay, so, and then all I'm going to do now is std accept. I'm basically going to say if, oh hang on, I've missed, okay, fine, let's do it this way. If not handle, then throw std runtime error failed to open process, because that's a class invariant, right? We want this class to only be valid if it could open the process. If we go back to what Windows said we should use the enum process modules. So we'll get the docs up for that and see what hilarity ensues in there. Retrieve a handle for each model in the specified process. So a module is a XE or a DLL. So an executable will load multiple DLLs, so it will have multiple modules. So when you go through all the modules, you're effectively going through all the libraries that it's loaded. However, the first module in the module list is the executable itself. So what we're going to do is we're effectively going to enum process modules, but we're only going to enum up to, you're only going to enumerate up to the first element, because that will be the executable itself. So it takes a handle to the process. Again, that's why we have a handle. It takes an array that receives the list of module handles. So this is where we're going to store the retrieved values. The size of the module array, again in bytes, got to watch out for that. Sometimes it's number of elements, sometimes it's bytes. And then the number, it will give us the number of bytes required to store all modules. Bytes needed equals not. And then if k32 enum process modules, it takes our handle. So this is why we have the cast operator for our auto release. It means we can just pass in our handle here, and we don't have to call .get or anything on it. It's just it will just work. So this is a little trick you can do. The API wants an array that you will write all those all of its results into, but I know I only want one, and I'm going to tell it that I only want one. So you can just give it the address of a single variable, and the address of a variable is the equivalent of, so this will give it a pointer to this variable, which is the equivalent of an array of one element. So we should say, hey, just write this, the result of this, straight into here, and then the size of is just the size of that object. Okay, so then we're going to need some strings, which we've already got included. String, right. Well, actually, before we go on to that, let's actually look at what the docs say rather than blindly guessing. So back to our little Windows approved tutorial. Well, it's not tutorial, example. You then, once you have your module handle, you can then say, hey, get the module base name, and that is the string we want. That is the name of the executable. So what does this say we need to do? Retrieves the base name of the specified module. So give a handle to the process that contains the module. So this is our that's our process. You then give it a handle to the module, so it's h module, and then a pointer to the buffer that receives the base name of the module. If the base name is longer than the maximum number of characters specified by n size, the base name is truncated. So you're going to give it a pointer, you're going to give it an address for it to write the string name of the module, and you're going to tell it how many characters it can write up to, and it's basically going to write up to that point, and if it can't write anymore, it will truncate it. So string module name. So we can give it a string that is the max path in length. So the maximum path is a Windows define, which stores the largest a path can be on Windows. So it's the maximum number of characters that any path can be. So we would hope that the path include, the file name for this executable must be less than the maximum possible path you can represent on Windows. Otherwise, it wouldn't be a valid name. So we basically just say, we're going to write into that many bytes, and then we'll just trim off the end. Chars written equals k32 get module base name A. We want the ASCII one, not the string one. I think we pass that. Sorry, I've got the docs up on the another window to get the handle, which again, cast operator, we can pass that straight in. Pass in our module. Pass in our module name dot data. So that'll be a pointer to the data, and then module name dot size. So how many bytes that we're going to return, and then after this. So let's give the user the ability to search for a process by name and get all the processes that match that. Again, I think we saw in that list, like there might be multiple PIDs for a given name, like Firefox will just spin up a whole bunch of processes. So let's get it so we can say, hey, get me all the PIDs that match Firefox.exe. Process procs, and then return procs. Right, done. We're done. Ship it. So now I should be able to just abstract away. I should be able to just, in fact, actually, I should be able to just take this and bring that into, nope, steady. Bring that into here. Don't need the namespace because I'm in it. Don't want to print. And then try creating the proc. And then if proc.name is equal to the name we suggest, then procs.pushback stood move proc. So what this is going to basically do is go through all the PIDs. You're going to go through all the PIDs. For each one, it's going to try and create one of our process wrappers around it. It's then going to try and get the name of, using that wrapper, trying to get the name of the process. If that name matches the supplied name, it will then transfer ownership of that constructed process into the vector, and then we'll return all those at the end. All right, now we'll go back to main, and then we can do for const auto proc in bio find process firefox.exe. So at this point in this loop, we know we only have valid processes mapping this string, so we don't have to worry about try catches or anything else. This is a much easier and more intuitive API for our users to use. And boom, there we go, done. Okay, I'm quite pleased with that. I think this is a good place to stop.